Okay, starting recording. Transformations of basic curves. There are basic curves that you are going to have to know off the top of your head what the graph looks like. The more of these you know, the faster you'll get finished with your homework.
Parabola.
So these are all called parent functions. The parent function is the one that is basically the smallest or most simplest one, the starting point for everything, you know, like your parent. Now, this is a quadratic function. Where is the vertex?
Zero.
Okay, it's at 0, 0, or the origin. Okay. What does the x cubed function look like?
It's like a little snaky thing.
Okay. All of these values that are positive, you put them in. 1 goes to 1, 2 goes to 8, right? All of the negative values are negative because it's cubed. There's an odd number of them. What does x to the fourth look like?
It's a parabola.
It looks like a parabola. Anything x raised to an even power is going to have that same look about it. The difference is it's a little bit wider here at the bottom. The larger your exponent is, the wider it is at the bottom, and it kind of flattens out, okay? So looks still like the parabola, a little bit wider, okay? What does your square root function look like?
It's just a line out of the 0, 0.
Starting at 0, 0, kind of a half of a sideways parabola. Okay. And then the absolute value function, what does it look like? The value starts with a V, and so your graph looks like a V. Absolute values look like a V. Straight lines, V's. Okay, so those are the basic ones. And as you go through the lesson and you're graphing these, you're going to want to keep a few things in mind. What's happening and how does it affect the graph? Some of you are going to need to type these into the calculator and look at the graph and find nice points, okay? But I want you to start paying attention to if there's a negative in front of a parabola. What does this negative do to this graph?
It wants to go down.
Yes, and the mathematical name is the reflection about the x-axis. Reflection about the x-axis. Now, why do you think it's important for me to say the x-axis?
Because if it's y-axis, it would be
So what makes it reflect about the y-axis?
a negative.
Inside the function. Yes, the negative inside the function. So if I had this x squared, for instance, it would be a negative x squared. Okay, so it would be inside the function. If it's the absolute value or if it's underneath the square root, there's a negative inside of that function.
It's a reflection of the y-axis.
Mm-hmm. So reflection about the y-axis. Okay, now, thinking of your graphs that you did yesterday. If there is a plus or minus value, so x squared minus 4.
It moves where the intercept is.
It moves your intercept or your vertex down if it's negative, and if it's positive, it moves it up, however many it is. Okay, so this one would be a down 4. The graph is still a parabola. It's taken that vertex and moved it to 0, negative 4, The rest of it stays the same. Okay?
Do we need to figure out the points exactly, or?
I want the point that I'm most interested in, that I'm going to be looking at, is this beginning point, the vertex, the max and the min, and like that starting point on that square root. That's where I'm going to be focused on. Okay? So if I have the absolute value of x minus 3, where is my vertex? 0, negative 3. How do I find another number if I'm graphing it? Well,
You put it in your calculator.
but there's a way that's faster than typing all of these into the calculator. How would I find it? I know I'm at 0, negative 3. That's my vertex. How about plug a 1 in?
1
What's the absolute value of 1?
plus or minus.
It's 1, negative 2. And there's a mirror image because of the symmetry. And you're done. Okay?
We can't see it.
Now, yes, you can type all of those into your calculator. That's fine.
Are we just graphing on today's lesson?
Just graphing. Yes, yes. All right, let's move on. What does a number in front of your function do to your function?
Moves it left or right?
Nope. Nope.
Or makes it skinnier or fat, stretches?
It makes it wider
Stretches
or skinnier. Now, if it's greater than 1, does it get skinnier or wider?
It stretches.
It does. It stretches. It stretches. So if I have my x to the 4th here and I put a 2x to the 4th, the red one is going to be the one that has stretched. So it has become skinnier. It's stretched. So what happens then if the number is, say, a half?
It'll still stretch.
It'd stretch. It'd be a little smaller. It'll be a little smaller. A lot smaller, apparently, by the way you're smiling.
It depends on what the number is.
Excuse me.
Okay. So the y values are getting smaller. The number, whatever, remember f of x is y, right? That's your function. So this is taking your value of f of x and multiplying it by 2. So your y value is getting bigger faster. This one is halving it. So the y value is getting smaller than the original. Okay? And we call these vertical because they affect the y. This is a vertical stretch. And this one is a vertical shrink, or you'll hear it called compression, a vertical compression. So you guys were talking about horizontal. Where would the 2 go to make it a horizontal stretch or a horizontal shrink? Inside the function f of 2x. Now, you also said something about a left-right movement.
Negative.
So let's go back to completing the square, vertex form of the parabola. We have a parabola in vertex form where we had, say, x plus 1 squared.
Well,
How did that parabola move? Do you remember? Which way over, left or right?
Right.
Left.
left because it's always opposite, right?
Yeah, inside the function, it's opposite of what's going on. So this is a left movement of 1. So if I have this x plus 2, it would be a left movement 2. So you're in the idea that it's the opposite if it's happening inside the function, correct? So if you have 2 times the x inside the function, what happens to your graph?
It gets bigger.
It doesn't double.
It
What?
divides out.
It divides, it halves it because it's the opposite operation. Because if you are adding, you go left. If you're negative, you go right. So if you're multiplying, you divide. So we say that these are a horizontal because it's happening to the x value, and that moves it left, right. Okay? And if it is 2 times, it's a horizontal shrink because think opposite. So if it's being divided by the number, it's a horizontal stretch. Okay, so those are the ones that are going to be a little bit more difficult.
Does that say?
X over 2?
Yeah.
Okay, so how, why? Okay, so I'm going to be graphing this. This is an absolute value, so it's a V shape. Where is my vertex?
No, 3, 1.
It's the opposite of the inside and the same as the outside. So 1, 2, 3, and up 1. So this point is 3, 1. What does the negative do to the graph?
Moves up. Right
To go down.
It reflects it
Reflects
about the x-axis, and you basically have the stretch factor of 2. Now, if it's a line, if it's absolute value, you can think of those as the slope. The slope is a negative 2. So you're going to go down 2, right 1, and then because it's an absolute value and we know our vertex, we can reflect that point to the other side, and that tells you how wide to make it.